In this demo, I'll be discussing the new types pattern. The new types pattern leverages the Rust type system in order to make your programs more reliable and easier to manage. Here we have a structure called never0, and it contains a single element, which is an i32. This type of structure is called a tuple structure because instead of using curly braces and having named values, it uses parentheses similar to tuples. We then have an implementation of never0, which we'll be implementing shortly, and we have a divide function, which divides an A and a B. The A is an i32, and the B is the never0 type. As you can imagine, the purpose of this never0 structure is to contain a number which is never0, and we're going to be using that to access the divide function. Normally, you cannot divide by 0, and if you attempt to do so, you'll crash the program. And as you can see, our divide function returns an i32 instead of a result, and we're able to do that because of this never0 type. I'm going to implement the new function on the never0 to ensure that this type can never contain a 0. We can do so with a simple if expression. So we can just put if I is equal to 0, we'll return an error. And if it's not 0, we'll just return a never0 containing whatever value the user supplied. And that's all we need to do in order to implement this structure. So whenever you want to use the never0 structure, you'll just call the new function and supply your value. And this value cannot be 0, as we can see here. We check, and if it is, we'll return an error. And if it's not 0, we return OK, and we'll have a new never0 structure that's wrapped up in a result. It is technically possible to create a never0 with any value by not using the new function. However, that's only possible within this single module. If you were to place this never0 structure in a separate module, then you would not be able to create it without any functionality. And then you would want to make this function public. And so the only way to create a never0 would be to use this public function. In this demo, we only have a single file, but in code that you write for your programs, you should utilize different modules in order to take advantage of this feature, as well as have better code organization. So now that we've completed our never0 structure, we can now use it within our divide function. What I'm going to do is access this inner value of the never0 by just reassigning the b. So we'll let b equals b dot 0. So if you recall from the lecture on tuples, to access the fields of a tuple, you just provide the index. So this is a tuple structure, and we only have one item, and the index starts at 0. So we can access it using the structure dot 0. So this will contain our value, which is an i32, and then we can just do a divided by b. And our divide function is now completed, and it will always succeed because the never0 type cannot possibly ever be 0 because we ensured that this is enforced right here. This will allow us to run our divide function quickly, and we don't need to check to see if there was an error dividing because we know that it will always succeed since we can never have a 0. I'll write a short program just to ensure everything works. So we'll just match on the never0 new function. We'll give it a 5. We'll call it nz, short for never0. We'll just divide 10 and the never0. If we get an error, we'll just print out the error. We'll also print out our result. Okay, so we should get 2 because 10 divided by 5 is 2. I'm now going to attempt it by giving it a 0, which should return an error because it'll check right away to see if it's 0. And then our match arm should hit error, and then we should get the error printed out. So let's see what happens now. As we can see, we got cannot be 0. It's always a good idea to try to use the new type pattern whenever you see an opportunity to do so. As we can see, we have the divide function, and we know when we divide by 0 that it's an error. So we can just create a type that encapsulates an i32, as we did here, and ensure that the value cannot be 0. And thanks to the Rust type system, the only way to create this type is to do so through the new function, which enforces that it's always never 0. We can also see that utilizing the new type pattern makes the divide function more performant because we don't need to check for the 0 value within that function itself since it's checked elsewhere. So if we're using this b value in multiple places, overall the program will run in a more performant manner. And additionally, it may be easier to use this divide function since it just returns a value. It doesn't return a result. So we can just take the value straight from the divide function and use it with another mathematical operation. This concludes the demo on the new type pattern. I'll see you in the next presentation.